Thank you, Michael. Hello, everyone. I'm Hanan Hibshi. I'm a assistant teaching professor here at CMU. I mostly teach security courses. So I teach the intro course when grad students come to CMU, and if that wasn't scary enough for them, I'll teach them browser security and secure coding until they reach a point where they creeped out, literally. In our last lecture, a student did a presentation and they had a survey to see if students are following, and nobody scanned that QR code. That's the kind of creepy students I create. But here is my relationship to this. I figured one of the challenges I face when I teach students is that I worry about taking that knowledge to the workplace. When they go to industry, are they going to remember the practices? Are they going to apply it when they write code, or was it just good enough to do the assignments? The other thing is, when we teach things like buffer overflows or pointer security, we usually talk C and systems language. What if they go and write code into other languages? Are they going to still apply the same concepts and look for similar vulnerabilities? And we've seen that that is anecdotal evidence here and there, and some other research that points that that actually is not the case. We do see vulnerabilities in other code bases that are not C. So to look into this even deeper, I said, here is an idea. I do teach cryptocurrencies in my intro class. So maybe I'll change the assignments, and now the assignment will be about blockchain. So most of my assignments are based on CTFs. I have a set up CTF server that has a platform similar to the Pico CTF platform that we run at Scilab to teach cybersecurity education to all students all over the world. But I have an instance for that that's more private, and I use it for my own classes. So I said, okay, I'll work with Arjun, who is sitting at the back here, and who jumped to the challenge and said, yes, this is an exciting problem. Let's create some blockchain challenges and put them in the homeworks and see how students would do. So at that time, when we started in our pilot in 2022, we said, let's start with Algorand. It's a proof of stake. It's a new language to students. It's not something that they're used to. So we're achieving many goals here. We're teaching them to get comfortable with something new that they didn't see in their classes, how well they're going to be doing with that. And then after that, we introduce some vulnerability in the smart contract code, and we'll see if they're going to be able to think outside of the box and apply the knowledge. We had some challenges at the beginning, so the server did go down the night of the submission, even though we tested it many times. So one backup plan we had is we had a paper version where they have to theoretically trace the code and tell us what's going on. And we made it harder than the actual challenge, because the challenge was written in PyTeal, which is the wrapper around the Teal language that they actually have to understand to work with Algorand. But the question and the hard copy of the question was in Teal itself, so it would require them to understand more about the language itself. But we had a very good response. The solve rate was very promising. According to the questions we got from our discussion forum and the questions that came to the TAs and Arjun at the time, we figured that the hurdle for them is to understand how this code works. So the first challenge is about understanding how smart contracts work. And once they passed that, they were actually able to see the vulnerability. But even though that was promising, we figured maybe we can make it harder. Maybe the vulnerability was easy to spot. So before getting so excited, we continued with the same thing we're doing from fall 2022 to spring and fall 2023. Now in spring 2024, we also didn't change as much, but most of our focus was actually to get the challenges to be stable. There were many updates happening. There were many platform issues. We had to sometimes go and get in contact with the developer teams. We have to keep following updates to make sure that we don't run into future issues. And here is a sample of what the code looked like for students. It looked like just any code they would interact with in languages like Python or Java. And for those of you who hate looking at code, I'm sorry, I didn't mean to teach you code, and I promise I'm not going to do that. But basically, a student who takes lots of secure coding classes should be able to see that there is some 8-bit limit here on a kind of a variable, and when they see this, they should immediately think of what we call integer truncation and then integer overflows. So that's where we were going with this. This is ongoing. We have a plan for this summer, thanks to the funding we got through Scilab, where we want to have more sophisticated examples. We want to advance the vulnerabilities. We tested this in my intro class, in my secure coding class, and in my browser security class. So we figured we will change the challenges for the context of those classes. I will have more System-Z related challenges that are more advanced that I'll introduce in my secure coding class, and then I'll figure out a challenge that relates to web and browser security, and we'll put that also in a smart contract code in our browser security class, and we'll test how students would react to those. We also want to test different vulnerabilities with different code from blockchains outside of Algorand, and this is work to be completed over the summer. Thank you. Hope I didn't go over time.
Hanan, if anyone has a question, please go to the mic.
Wonderful effort. Thank you so much for sharing. I'm coming from a hard cyber world, like where workforce is a major issue, right? Finding experts and this problem about training even just any kind of software developer to think about security from the beginning. How much tougher, are you finding it to find people that have expertise and understanding in blockchain as well as in security? And do you feel that there's, other than, I know you're pointing to trying to train people and help them understand, what are your thoughts about some of the measures to help scale this kind of capacity and the concept of security by design coming in from the beginning in blockchain platforms?
Well, that's a very long answer for a question, but here's my short tip. In the class I teach, my intro class, where we introduce this, we deal with grad students coming from universities all over the world, including smaller US universities here that maybe they never touched smart contract code before. So one of the things we achieve in that class, and as you can see, I had 100% solve rate, is that one, I make it clear for students, you're going to get your hands dirty. I'm not going to teach you in lecture and then you just forget about this. The homework is another world. One of the complaints we get is that, but you didn't show us a solution in lecture. You talked about cryptocurrencies, but you don't show us a demo on how to solve things like the homework. I'm like, yeah, welcome to the real world. Nobody's going to show you, and no TA will be in the room. They'll throw documentation at you, and you'll have to figure them out. Even when TAs run a session for the recitation, I tell them that they tell students to read manuals, to read the documentation before they come to questions, and point them to those resources, because these are skills that students need to build. Now, the good news is I've seen 100% solve rate among people who came from CS backgrounds, ECE backgrounds, and from policy backgrounds. There are some students who come from the Heinz School who try to beg and get into my course, and I make it very clear that they have to have some programming background before taking the class. The cryptocurrencies part of the class is not where they struggle. They would struggle when in the buffer overflow and the software security section of the class, because that's C and that's very System-Z. But we tried to do some to provide some resources through recitations to help bring those students up to speed. But my tip is get them to mess around with code, because they need to see how it works actually in real life.
Wonderful, thank you.